Oh, hi again, everyone. We are continuing from the previous video. So from where we ended up last time. So this is just a continuation of where we ended up. So for those who will be looking at this video, please check out the previous one, the one that we uploaded before this one. So we are doing momentum and impulse. So this is for grade 12, and last time we were talking about the relationship. We ended up speaking about the relationship between the impulse and the momentum, and we said that the relationship is that the impulse applied to an object is equal to the change it undergoes. So the impulse applied to an object is equal to the change in momentum that it undergoes. So we say that the notation of a momentum is this capital letter J equal to momentum was denoted as P. This P here stands for momentum, and this notation here, delta here, simply means the change. So that notation simply means is the change is the final minus initial. So this notation simply means just going to be taking a final mass or final velocity or final whatever, subtracting it with the initial part of it. So that is what change simply means. So just going to taking, so the change in momentum is going to be the final momentum that which is a pf minus pi, which is the initial momentum. So the f here stands for final, the I here stands for initial. Okay, so the relationship between the two, it is that this impulse is equal to the change in momentum. That is the relationship between the two. So because of the equal sign here, that simply means we can conclude that the J is directly proportional to the change in momentum, meaning that impulse is directly proportional to impulse. So this notation I've written here simply means directly proportional, guys. And what does this notation means? It simply means that you will be taking, direct proportional simply means that when one thing increases, so the other one increases. If this one increase, then for it affects this one to also what to also increase. If this one, the change in momentum, decreases, it also affects, if the impulse decreases, it also affects the change in momentum to also decrease. So that is what this notation here of directly proportional means. It simply means that when the other one increases, so as the other one increases. When the other one decreases, so as the other one will also decreases. So that is what this notation means. So the impulse will be directly affected by the impulse will be directly affected by the change in momentum. And then moving to the applications of momentum. So the application of momentum, it is not exam based, this part, but it is very important for you to also know that the word application of momentum and the impulse. So the first application is that momentum and impulse, they are applied in collisions, guys. So you'll be for the practical part, or the questions, the assessment questions on this topic, they will be mostly based on assessing you with the scenarios that deals with the collisions. So they will be dealing with most of the collisions, studying different scenarios of collisions, studying different situations that might happen within collision, and then you'll be applying momentum and the equation for conservation of momentum to actually solve most of the of these of those questions. And then from then you will be application of momentum and impulses on the spot. And then lastly, momentum and impulse is applied in our daily life. So the last two, guys, they are not mainly important, but it's good for you to also know them. But the first one, which is that one of a collision, definitely you will be having questions whereby they will be asking you regarding solving momentum and impulse using the within the collision scenario. Yes. And then firstly here we will be taking a look at the derivation. So this is the derivation. Derivation simply means that you, because you know the formula, so here we're just going to working on how was the formula built, how did they come up with that formula. So that is what derivation means. So you're just going to be taking a look at how did they come up with the formula for impulse. So firstly guys, as you can see here, f net, so this is the first step. F net is equals to ma. So the F here stands for the force, the net here stands for the net force, meaning that the sum of all the forces, it is equal to ma. M is what is the mass, a is the acceleration. So I hope you are now familiar with this equation guys. Try to recall, where have you seen this equation before? Exactly, you have seen this equation from Newton's second law. So Newton's second law, which is m2, tells us about that equation, which that the sum of the forces is equal to the mass multiplied by acceleration. Okay, and then the f net is equals to ma. We now know that the acceleration, definition of acceleration, is defined as a change in velocity. So a is the change in velocity, meaning that for acceleration you can write delta change in v delta t, which is, this means the acceleration. And then from then afterwards you can break down this velocity. We have spoken before that the change in v simply means final minus initial. So the change in v will simply means that final velocity minus the initial velocity. So that's what they've done here on this step. They've just broken this change then of v to be final v minus the initial v, and then for the change in time they've written it the way it is. They didn't change anything. Then from here they applied FOIL method. So this multiplied by that one multiplied by that one. So you're going to be having mvf minus mvi there. And then from here afterwards, we now remember that the mv, as we have said guys, mv denotes what? Denotes the momentum. So since we can see, we can call that mv denotes momentum, this is mvf, that means this is going to be the final momentum. This one is going to be the final momentum. And then this one, since it's mvi, that means it's going to be the initial momentum, since we know mv is the momentum. Okay, and then so we are going to be having pf minus pi, which is final momentum minus initial momentum, divided by the change in time. We now remember that the pf minus pi, which is the same as the change in momentum, because of just going to be taking the final momentum, subtracting that momentum with the initial one, and then that is going to be the change in p divided by the change in time. So this here guys is the equation of impulse. So last time they were writing it like this: change in p is equal to f net multiply by the change in t. So here I've just made changing in p to be the subject of the formula, but this is basically how it came to get to this form guys. They've applied all these steps here to actually take us to this last step of it. Okay, so please guys, if you find this video really helpful, do share it and also comment, like and follow. Thank you so much for watching.